How do the different placements of Na in the O3 phase and P2 phase influence the properties of the material, and what might be the physical or chemical implications of Na being in octahedral versus prismatic sites? Does the transition between these two phases, O3 to P2, involve any significant changes in the material's structure or properties, and if so, what are they? What kind of transition metal ions Fe, Ni, Mn, Co, etc. are typically used in these compounds, and how does each metal ion affect the overall structure and behavior of NaMo2? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How might the choice of transition metal impact the performance of NaMo2 in practical applications, and what are some potential uses for these materials? How does the crystallographic phase, O3 versus P2, influence the performance or stability of NaMo2 in various conditions, such as in energy storage devices like batteries? Are there any known advantages or disadvantages of the O3 phase over the P2 phase, or vice versa, in terms of their practical applications or theoretical properties? What are the electrode reactions in an ion battery, and what is the role of the anode and cathode in these reactions? How does an ion battery differ from other types of batteries in terms of its electrochemical components, and why is it important to understand these reactions? What materials are used for the anode and cathode in the specific Na-ion battery, and what are their properties? What is meant by a hard carbon, C6, anode, and how does this material contribute to the overall performance of the battery? Why is hard carbon, C6, chosen for the anode, and what are its advantages and limitations compared to other possible materials? How does the choice of hard carbon affect the battery's charge and discharge characteristics? What exactly is a layered transition metal oxide cathode, and how does it differ from other types of cathodes commonly used in batteries? What role does NaMo2 play as the cathode material, and why are compounds like NaMo2 used in these types of batteries? What are the specific properties of NaMo2 that make it suitable for use as a cathode in Na-ion batteries, and how do these properties contribute to the battery's overall efficiency and stability? What are the reactions at the cathode and anode during the charge and discharge cycles in a Na-ion battery, and how are these reactions represented in equation form as indicated by EQ1? What does it mean for the discharged electrodes to be on the right-hand side of the equation, and why is the location of these electrodes important in understanding the reaction? What happens to the anode and cathode during the discharge process in a Na-ion battery, and how are ions involved in this process?